All right, Math 2, here we go. We've got lesson 9.4.1, inverse functions. All right, so when we have 3 and it's input into this function machine, the output coming out here is 13. So 3 goes in, we do some operations with it, out pops 13. All right, when 4 is put in, the output's 16. When -3 is put in, the output's -5. We want to write a function for that one. So if we look at the inputs and outputs, wow, that was really weird. I don't know how that happened. All right, so we put in 3 and out pops 13. We put in 4 and out pops 16. So at this point, we can kind of just look at these two and we can ask ourselves, does this look like it's linear? Does it look exponential? Does it look like it's quadratic or something like that? So far between these two, if we're assuming that it's going to be linear, it looks like we're adding 3. But just having 2 points isn't enough to really see what's going on. So we should probably check out the next point. The next point, the input was -3. And then the output was -5. All right, so if I was going from 3 backwards to -3, I would go back a total of 6, right? To go from 3 to -3. So that means that I would do the opposite of adding 3 6 times, which would be subtracting 3 6 times. So that's subtracting 18. So if I take -13 or 13 and subtract 18 from it, I do get -5. So now I can tell that I was adding 3 each time. Again, I see when I go from 3 to -3, I'm going backwards 6, which means from 13 to -5, I should be subtracting 3 6 different times. And that's -18. So 13 minus 18 is -5. So yeah, that is linear in what's going on here. So we know now that our slope is 3. And then using y equals mx plus b, we know that m is 3, the slope. I can use a y of 13 and an x of 3 to find the y-intercept. I get 13 equals 9 plus b. Subtract 9 from both sides, and it looks like my b value is 4. So I think my equation is y equals, or f of x equals, doesn't matter which one we do, y equals 3x plus 4. And we can test it out to make sure it's working. Like if we plug in 4, I get 12 plus 4 is 16. Yes, it's working. So we've got the correct function there. The inverse of a function is written as f to the -1 of x. Makes a function work backwards, where we plug in 13 and we work backwards to find it. So if I were to plug in 13 into the function, I should get 3 as an output. If I plug in 16 into the function as an inverse, I would get an output of 4. If I plug in -5, of course, I get an output of -3. So an inverse just works backwards. The output becomes the input, and the input becomes the output. So if I'm going backwards, what operations is happening? Well, the opposite of these operations is what's happening. It looks like when I go forward, I multiply by 3 and then subtract 4. So if I want to go backwards, if f of x, the order of operations, is to first multiply by 3 and second to add 4, that's what this says, the inverse would go backwards and do opposite operations. So the inverse would start by subtracting 4 and then divide by 3. It's basically undoing this order of operations. So we just go backwards and undo the order of operations. So write the equation for that inverse function. We would subtract 4 and divide by 3. So there's the function backwards. Now what we can do to find the inverse is take the original function and switch the x's and the y's. So the x would go over here, and the output y would go here. So I would subtract 4 from both sides. I get x minus 4. And then divide by 3. All right, so the steps for the function are multiply by 5, subtract 8, then divide by 2. What is the equation of g of x? Okay, so g of x, we're supposed to take x, multiply by 5, subtract 8, and then divide by 2. So there's our function. If I wanted to do the inverse of that, I would go in reverse order and do the opposite operation. So g of -1, I would start by multiplying by 2. Then I would add 8. And then I would divide by 5. That would be the inverse of the function. Sorry, I didn't realize that I wasn't moving this. Now you can see it. I'm not going to redo this. I'm already 7 minutes in. All right, again, to solve this, I could have made this x and this y and then just undone the equation. I should really start watching my screen. All right, Esther is planning a trip to Japan and wants to know what the weather is like so she can pack. She finds out that during the day, the temperature is 30 degrees centigrade, and at night it's 25 degrees centigrade. But Esther's from the US, she doesn't use centigrade, she uses Fahrenheit instead. But Esther does know that water freezes at 0 degrees centigrade or 32 degrees Fahrenheit. She also knows that water boils at 100 degrees centigrade or 212 degrees Fahrenheit. So we want to write a linear function to convert Fahrenheit to Celsius. All right, so I'm going to say that, let's do x is going to be Fahrenheit and y is going to be Celsius. Is that what I want to do? Yeah, that's what I want to do. So this is Fahrenheit degrees, this is Celsius degrees. So I've got 2 points here. I know that when it's 32 degrees Fahrenheit, it's 0 degrees Celsius. And when it's 212, it's 100 degrees Celsius. So I can start by finding my slope. Remember that it's the change in y over the change in x. So I do 100 minus 0 over 212 minus 32. We get 100 over 180, not 180. 180, yeah. Let's see, we can take off the zeros. So reducing this looks like I get 5 over 9. So my slope is 5/9. Now I need to find out what the y-intercept is. So I use y equals mx plus b. Y, I'm going to use 0. M, 5/9. X, 32. Plus b. All right, so when I multiply this out, I get 5 times, that doesn't reduce at all, does it? So 5 times 32 is 160. And then I would subtract that from both sides. And I get b equals negative 160 over 9. So my equation is y equals 5/9 of x minus 160 over 9. Can we make this easier? Oh yeah, we could. I could factor out like a 1/9. Oh, I can factor out a 5 as well. So I already know 32, that was 5. Okay, so if I factor out a 5 as well, I get 5/9 of x minus 32 because I already knew that 32 times 5 was 160 from over there. All right, that looks a little bit better. All right, so there we go. Now write an inverse function. So this says that if I plug in Fahrenheit, I can find Celsius. But in her situation, Esther knows what the Celsius is, but she doesn't know what the Fahrenheit is. So she wants to be able to plug in Celsius instead of plugging in Fahrenheit. So in order to do the function, I can switch the x's and the y's to do the inverse function for this. So this is Celsius equals 5/9 Fahrenheit minus 32. So I can start by multiplying by the reciprocal of 5/9, that's 9/5, or 9c over 5. And then I can add 32 to both sides. So now I've got 9/5 of Celsius plus 32 equals Fahrenheit. So now Esther can just plug in her Celsius numbers to find out how hot it is in temperature that she understands. So if she knows it's 30 degrees and 25 degrees, we can do 9/5 times 30 degrees Celsius plus 32. So 5 goes in there 6 times. 9 times 6 is 54. And it looks like it is 86 degrees. All right, so she might need some shorts or a skirt or something like that because it's a little bit hot during the day. And at nighttime, when it's 25 degrees Celsius, oops, fifths. Five goes in 25 5 times. 5 times 9 is 45. 45 plus 32 ends up being 77 degrees. All right, so she doesn't need a jacket, that's for sure. It's going to be 86 during the day and 77 degrees at night. There you go. All right, let's flip it over. Write the inverse function for each of the following. All right, so when we do the inverse, this is the y, this is the x. So the inverse, I switch them. This is x, this is y. So I add 12 to both sides. And then divide everything by 4. So if I divide this by 4, I get 1/4 of x. Divide that by 4, plus 3. So that's the inverse. Over here, we switch. This becomes x. This becomes y. Why did I do 2 y's? I don't know. So I would multiply by 10 on both sides. And then add 7. And y would be 10x plus 7. Okay, write the inverse of this one. Again, we switch x to y minus 1. I add 1. And I divide by 2. Y would be 1/2 of x plus 1/2. All right, so we've got h of x and h to the negative 1 of x, so the inverse of x, h of x. State the intercepts of each function. All right, so h of x, the x-intercept is when y is 0. So I would add 1, divide by 2. So that would be 1/2. The y-intercept is the b value, negative 1 over there. The inverse of that, the x-intercept of this one, if I plug in 0 over here, I subtract 1/2, and then multiply by 2. That gives me -1. Oops. So I subtracted 1/2, and then I multiplied by the reciprocal of 2. I got -1. The y-intercept, our y values over here, our b value, sorry, our y-intercept, it's 1/2. So we can see that the x-intercept and the y-intercepts have switched places when we do the inverse. All right. How can you quickly determine a table? Oh, we're supposed to graph it. So h of x has an x-intercept of 1/2, has a y-intercept of -1. There's our function. And then over here, we've got a x-intercept of -1 and a y-intercept of +1/2. There. Oh, that wasn't good. So our other function ends up looking like that. Okay, how can we quickly determine a table for the inverse? Well, the inverse switches the x and the y. So we would just do -7, -3, -5, -2, -3, -1, -1, 0, 1, 1. That would be the same point. 3, 2, 5, 3. So the inverse just switches the inputs and the outputs. All right, almost there. Use this function, the parent function of the quadratic, f of x equals x squared. Make a table from -3 to 3 and then graph it. We don't really need a table for the parent function. Add 0, 0, over 1, up 1, over 2, up 1, 2, 3, 4, and over 3 and up 9. Oh, I see why they want us to do the table. 1, 2, 3, 4 would be up here somewhere. They want us to do a table so we can just switch these two numbers around. All right, so if our input is -3, we would get 9. -2, we get 4. -1, we get 1. 0, we get 0. And if we plugged in 1, we get 1. 2, 4, 3, 9. Okay, we would switch this around. The 9's not going to fit, so let's just do from -2 to 4. So I would go 4, -2. So 4, -2. I would do 1, -1. 1, -1. I would do 0, 0. I would do 1, 1. And 2, 4. So we can see when we did the inverse, it spun this one on its side. Does the inverse represent a function? Nope. This does not pass the vertical line test. When I plug in 1, I get 2 different answers. Remember, a function, when you plug in a number, it can only give you 1 answer. When I plug in 1, it's giving me 2 answers. That's not very helpful. I want 1 answer, and it's giving me 2 answers right here. It's also giving me 2 answers there. So it's not a function. What's the equation of the inverse function? Well, if we switch this around, we'd get x equals y to the second. So to undo squaring, we square root. So y would be the square root of x. There we go. We've got inverses. And we are done with Unit 9. All right, math hard. See you guys later. Bye-bye. Oh, wait, I forgot something. Sometimes we get stuff that doesn't work. I forgot about this. Let's look at some of these numbers here. When we look at the inverse, oh, I almost forgot about this. Good thing I remembered. If I plug in -1 to this, I don't get an answer. I don't actually get 1 because we can't have a negative radical. So actually, this part of the graph doesn't exist. The inverse of the function is only this section up here. So sometimes when you do an inverse, you get answers that don't exist in the inverse. In this particular case, you cannot input negative numbers because those are imaginary numbers. So the negative portion of here, the negative output portion actually doesn't work. And the only part of the graph that does work is this part up here. Ooh, almost forgot about that. Glad I remembered. All right, now I'm done. All right.